In this video, we are going to talk about planarity testing. First, let's talk about some of the terms that we are going to use. The first one is a piece. A piece of a graph G relative to G1, which is a subgraph of G, is defined as either an edge or a connected component of G minus G1 plus any edges incident with this component. Let's look at an example. On this graph on the left side, you see a graph here. Let's suppose this is graph G. And let's select the G1. Here, this cycle shown in color red, let's suppose this is G1. Now, let's check the pieces of graph G with respect to G1. The simplest one is this edge between nodes 3 and 5. So this is a piece. Here you see another piece, which looks like a triangle. And finally, here's another piece. A second term is named as points of contact. For any piece B, the vertices which B has in common with G1 are called the points of contact of this piece B. Again, let's go and examine the same example. Now, for example, the edge 3, 5, which is also shown here on the right side, redrawn on the right side, has two points of contact, 3 and 5, because those are the points that it touches G1. This triangle here has only one point of contact, which is 4. And finally, this piece here, the largest piece, has 3 points of contact, node 1, node 2, and node 5. Now, if a piece has 2 or more points of contact, then we call this piece as a bridge. Can you identify the bridges here by looking at the example? Well, B1 is a bridge because it has 2 points of contact. B2 is not a bridge because it has only 1 point of contact, as you can see here. And finally, B3 has 3 points of contact, which means B3 is also a bridge. In our previous discussions, we defined the blocks of a graph. In terms of planarity, blocks of a graph is an important part of the discussion because a graph is planar if and only if each of its blocks is planar. So in question of planarity, we are dealing with blocks, which means you can divide a graph into its blocks, if possible, and examine each block in terms of planarity, and finally decide whether the graph is planar or not, based on the planarity of its blocks. The final definition is in the next slide. Incompatible bridges. Now, we say that two bridges, say B1 and B2, are incompatible if at least 2 of their edges cross when placed in the same face of a plane defined by a cycle. Here is an example random cycle formed of 1, 2, 3, 4, 5, 6 nodes. And assume that we have two bridges, B1 here and B2 here. There is no way for us to draw these both of the bridges on the same face, because you can see that this cycle divides the whole plane into two faces. Remember the definition of face in a graph, in a planar graph. So in the interior face, when you try to draw the B1 and B2, you see that here two edges cross. And you cannot draw these two bridges in the interior. So one of them has to go to the exterior face. We will use this notion of incompatibility in our next video, where we discuss the planarity algorithm.